what? Derivative of the first times the second minus first times the derivative of the second. What's the derivative of g of x plus 2? Or two different answers. What's the derivative of 2? 0. G prime of x plus 0 all over the denominator squared. What's the slope? What's the slope of this function at x equals 0? Do we have enough information to evaluate it? Yeah? What's f prime of 0? Negative what? Negative 2. What's g of x? What's g of 0? Negative 3 plus 2. Minus what's f of 0? Negative 1. What's g prime of 0? 4. All over what's g of 0? Negative 3. Still right? What's the derivative of this thing? So if this is like an x squared, whatever it is, I don't know what it is, but it's the derivative of this, and so that the rule is you can take the derivative of each thing if you're plus or minus, and then the derivative of 2 is 0. Does that make sense? So what's the slope? Anyone got it? 6? Does anyone agree with 6? Okay, so this is, let's do negative 2. 6. Okay? What's the equation of the tangent line? What do you need for the equation of the tangent line? A point and a slope. You already got the slope. How do you figure out the point? I have a 0. I have an x value. Can I figure out the y value? Let's do it. And then give me the equation of the tangent line. Yes?
For e, why can't you just plug in the values
into this?
Yeah.
What? Great question. That's what you should be doing right now. And why? What happens if you what does f of 0 over g of 0 plus 2 give you? What is, in general, what is this going to give you in terms of this being the function?
The y value.
The y value at 0.
But why can't you plug in the derivatives? To get, I plugged in the derivatives, like f1x over g, like f prime x over g prime x plus 2. Why can't you do that instead of the quotient rule?
For the same reason why you can't just, okay, you have something like x squared over like 3x squared plus 5. If you wanted to evaluate this at x equals 1, can you just take the derivative of 2x, take the derivative of this, and then plug in the value?
I guess not.
But like, why? What do you mean you guess it? You know what I'm saying? It's like, to take the derivative of something that's in the quotient form, you have to follow this quotient rule, otherwise it's incorrect. You can take the division of each thing plus and minus together, or each thing separate. But a product is just like when you have x squared. What's the derivative of x squared?
2x.
That's 2x. Well, that x squared is the same as x times x. Well, if you take the derivative of each of these ones individually, that's 1 times 1. You know what I'm saying? Like, these derivatives aren't the same. So what we created, and if you do all those problems with the definition of the derivative, is this product rule comes out of it. And the same thing with the quotient rule. The more problems you do, this quotient rule comes out of it. You can't just take the derivative of each thing separate. It would be nice if we could, but we can't. Does that make sense? But again, you can always go back and use everything with definition of the derivative and get the value. But what the quotient rule is a trick, so you don't have to do that every time. Does that make sense? So this, what do you get here? 1? Okay. So we have our point on our graph. We have our slope. How do I create the equation of the tangent line? What is it? What's the equation of the tangent line?
1 minus 1 equals 6x. It's x minus 0.
Yeah. That or just 6x. Yeah. Okay. Again, you have enough information. You don't always need the entire equation. Sometimes all you need is just to know what that derivative value is. And you don't have to take it. Okay? So try a couple of these problems together. We get about 30 seconds. And work on them tonight.